Welcome to EDU World Space.
In this problem, continuation of a problem that we just did a moment ago, we're asked to find the direction that a boat should travel in order to move directly across a 500-meter wide river if the river itself is flowing downstream due south at 2 meters per second, and the boat is going to be traveling with a speed of 4.2 meters per second relative to the river. We want to know what angle should the boat drive at so that it moves directly across the river. So let's go ahead and draw a picture here to orient ourselves. Here's my 500-meter wide river, 500 meters wide. And what we know is that the river is traveling, or the river itself is flowing downstream at 2 meters per second. And our job is to figure out what angle the boat should be driving at so that we travel directly across the river as opposed to flowing down the river with the motion of the river. So we were told that the boat is going to be driving at 4.2 meters per second. Here's the key to solving this problem correctly, is that I need to recognize that whatever the direction that my boat travels in, the y component of the boat's velocity needs to counteract the 2.0 meters per second downstream flow of the river. So what that means, if I draw the components of my boat's travel, the vertical component, the y component, has to be equal and opposite to the direction of motion, or the velocity vector, for the river's flow. That way it'll counteract the flow downstream and the boat won't move relative to the shore in the north-south direction. And then whatever velocity is left over from the 4.2 meters per second vector that I'll draw here in a second, that's going to be my x component that's going to take me across the river. So let's see if I can try to make my vectors come out about the right sizes. So my boat's vector, total velocity vector, is just the resultant of those two component vectors I just drew, and that will be this one right here. And I think I did okay. It's about a little more than twice as long as the 2.0 meter per second downstream vector. So this is the boat's velocity, and it's 4.2 meters per second. Okay, so if I add together head to tail my 4.2 meters per second vector and the river's flow, right, that's this one right here, the 2.0 meters per second downstream, add those head to tail, then the resultant of those two, basically just adding my two solid blue vectors together, that will be my resultant vector. And that's what I'm going to try to find here. That should take me due east across the river. Okay, so the question we were asked is, what angle should the boat be driving at? What angle should that blue vector of 4.2 meters per second be in order that the red resultant vector goes straight across the river? So I just need to figure out what that angle theta I just wrote down is. So let's go ahead and see if we can do this with a little bit of trigonometry. So I know the opposite side of the right triangle I drew there, the opposite side from that angle theta. Well, that's just the, if I draw it in over here, right, that's just the direction of the river's downstream velocity and the magnitude of the river's downstream velocity. And I've got the hypotenuse of that little right triangle is the boat's velocity. So I can just use sine of theta here is the opposite side, 2 meters per second, divided by the adjacent side, divided by the hypotenuse, which is 4.2 meters per second. And then go ahead and take sine inverse of that. Your units will cancel out, and you'll find out that the angle that the boat should travel at is 28.4 degrees. And you might call that 28.4 degrees north of east. Okay. In part B, we're asked, what's the velocity of the boat relative to the Earth? And this is really easy. I just need to recognize that the velocity of the boat relative to the Earth is just that x component of the velocity, right? It's that red resultant vector that I've drawn there, which is due east across the river, so it's just the x component. So that's going to be the total velocity of the boat, that's my 4.2 meters per second, times the cosine of that angle that I just calculated, theta. So if I plug in my values there, that's 4.2 meters per second, the speed of the boat. And I want the adjacent side, which is the x component, which is that red resultant vector. So I'm going to take cosine of that angle I just figured out, 28.4 degrees. And if you work that out in your calculator, you'll get 3.7 meters per second. Okay, and then finally, we're asked how much time is required to cross the river. So that also is pretty straightforward, since I know I'm just driving directly across the river with that speed that I just calculated in part B. Then the time it's going to take to cross the river will just be the width of the river divided by that velocity that I'm traveling at in the x direction. So that'll be 500 meters divided by the 3.7 meters per second that I just figured out is the speed I'm moving across the river with. And that comes out to be 135 seconds. And those are your final answers.